Hello everyone. Today I'm recording this chapter 2 for the asynchronous class. So we can start from the force vectors. So before we proceed with the other contents, we need to know what are the vector quantity. And before talking about the vector quantity, we need to know what is the scalar quantity. So by definition, scalar quantity is either the positive or negative physical quantity that can be completely specified by its magnitude. For example, examples for scalar quantities like length, mass, time, speed, etc. So they are the scalar quantity because they only have magnitude, they don't have a direction. And vector quantities are those physical quantity that requires both magnitude and direction for its complete description. And examples for these vector quantities are force, position, moment, weight, velocity, acceleration, etc. So when you are comparing with the scalar quantity, and vector quantity, there are several vector quantity compared to the scalar quantity. A vector is shown graphically by an arrow, and the length of that arrow will represent the magnitude of that vector, and the angle made between the vector and fixed axis will be defining the direction of the line of action or the direction of resultant force. Vector quantity are usually represented by the boldface letters such as bold A, and the magnitude of the vector is italicized A. But whenever you are writing on the piece of paper by using your hand, probably it will be hard for you to make it bold. So instead of making it bold, we have another option to indicate the vector quantity, that is by putting the arrow over the certain given alphabet, like here. That is vector quantity. That is the convenient way. And you can see here in the diagram, so you will be able to identify the parts of the vector. Here it's a line of head, the arrow, then and the opposite side is the tail. The angle made by this reaction force or the line of action is the direction, and you can see multiplication of the magnitudes. So the length of this arrow will determine the magnitude of that vector. There are three types of vectors: free vector, sliding vector, and fixed vectors. The fixed vectors are those which has a unique point of application and it is specified, while sliding vector has a unique line of action in the space but unique point of applications. And similarly, free vector is one whose action is not confined or associated with the unique line in the space. So for the vector quantities, we can do the multiplication, division, addition, subtraction, etc. by scalar quantity. So if the vector is multiplied by the positive scalar quantity, its magnitude will be increased by that amount. It can be increased or it can be decreased by that amount of the scalar quantity, and the direction of that vector will be determined by positive and negative scalar quantity. Let's suppose if we have minus A, here in the diagram you will see A facing upward, while if it is a minus, the arrow will indicate downward. So scalar quantity 2A times 2 is the scalar quantity, A is the vector. So when you multiply by the 2 scalar, which is scalar quantity, the length will only be doubled. If you are multiplying by minus 0.5, so that is half of the A, here you can see in the diagram, then the since it is negative sign, it will symbolize the direction, which is opposite of vector A. We can perform the vector additions, which is essential part for this subject. You might need to do several vector additions, and these vector additions are possible in three different ways. One is by using the parallelogram law of additions, and even while using the parallelogram law of addition, there's further two more way. One is adding tail of the two different vectors, and from each of the vectors head we will draw the parallel line forming the parallelogram. From point of intersection of the tail up to the other intersection, we draw the diagonal. That will be the resultant force of that product of two vectors, the addition of two vectors. Here you can see vector r, which is the resultant vector we get by addition of vector a and vector b. So as I mentioned, first you need to join the tail of the component at the point to make them congruent. From the head of the vector b, draw a line parallel to a. Draw another line from the head of the vector a that is parallel to vector b. These two lines intersect at the point P to form a adjacent side of the parallelogram, and the diagonal of this parallelogram that extends from the point P will form the vector R, which will be the one which will be representing the resultant of the two vectors after the addition. Then we have triangle rule for the addition of the vector. So here in this triangle rule, we will not necessarily make the parallelogram, we will just occupy the half. So it's a special case of the parallelogram law, and most of the problem solving it's much more convenient to use this triangle law, but you might still need to make a parallelogram so that you can get the proper measurements regarding the scalar quantity and the angles made by each of the vectors. So here a special case of parallelogram law whereby vector b is added to the vector a in the head to tail fashion by connecting the head of the vector a to the tail of vector b, and the resultant vector r will extend from the tail of vector a to the head of vector b. So normally the direction of the resultant force will be the same direction where both vectors are facing. You can see here in this diagram, vector a is facing rightward, b is also facing rightward, right side. So when you add those two vectors, vector a plus b, the direction of the resultant vector will also be in the same directions. So that is adding head to tail. We can also perform the triangle rule by other way, vector b to a. So whenever you are doing the vector addition, whether it is a plus b or b plus a, usually the resultant vector will be, the value of the resultant vector will still be the same. The only thing is the direction. The only difference is, instead of adding vector b to a or a to b, the heads, the only that one will be different, but in terms of resultant vector, the direction will also be same, scalar quantity will also be same when you are performing the addition, either a plus b or vector b plus a. So that is the triangle rule. And we have another one more exception, that is a special case. Usually if happens whenever you are you have two vectors, both are traveling in the same directions, or we can say collinear. So in that time the line of action will be the same, so we cannot use the parallelogram law as well as we cannot use the triangle law. There won't be a triangle. So in these conditions we will just perform the algebraic or the scalar addition to get the value for the resultant vector, that will still be vector a plus b. Then we can also perform the vector subtraction. Usually the vector subtraction is just inverse of addition vector. or we can also define this subtraction as a special case of additions. The only difference will be the direction of the vector. So you can see that here in the slide, the resultant of the difference between two vector a and b of the same may be expressed as r inverse a minus b, which is also equal to a plus negative vector b. So a plus, we are going to add a to the negative b, so tail and tail. So we can just make a parallelogram law, or we can also make triangle construction. So whichever is convenient for you, you can perform that method. So usually it's better parallelogram law, then you can just transpose vector a, since it's parallelogram, the another side of the parallelogram will be equal, so you can transpose here. And even for this b, the direction of the vector and the scalar will be same, so we can just occupy half to solve the problems. So the most, rather than those additions, subtraction, multiplication and division of the vectors, the other essential thing for this subject is sine and cosine law. Usually sine law, you can use those sine law if one direction, one side, the value of one side is known, and either minimum of two angles, internal angle of the triangle is available, that time you can use the sine law. So sine law basically side divide by sine of the opposite angle of the side, given side, which will be equals to same, it's a ratio. And cosine law you can use usually if the value of two sides are given and the angle opposite to the missing side, the side with the missing value, you can use this formula. So usually cosine law is a is equals to root under b square plus c square minus 2bc cos a. So basically you can just memorize this part. So we have some examples. So example number 1, the screw I is subjected to two force F1 and F2. F1 is with the 100 Newton force, F2 is 150 Newton force. So from there you need to determine magnitude and direction of the resultants. So for that, basically you are going to do parallelogram, make a parallel free body diagram, and by using the parallelogram law. So you draw the parallelogram here, we can see the diagram here. You draw the parallelogram free body diagram, then parallelogram opposite of F2. So once you have a parallelogram, you can also get the resultant vector, which will be Fr. So since internal angle of the sum of internal angles of the parallelogram square or the rectangle is equals to 360 degrees, and opposite angle of each of the parallelogram are equal. So for here only two angles are given, 10 degrees and 15 degrees. So the total is the perpendicular, so it should be 90 degrees. And you, as per questions, you are going to find the value for the angle made by this Fr to the horizontal plane. So internal angle of this parallelogram of its one angle should be equals to 90 minus 10 minus 15, so that should be 65. So this internal angle in this point is 65, so it should also be opposite, same to the opposite angle, so it's also 65. So by the theorem we know that 360 degrees is the total sum of internal angles of the parallelogram. So we can do is 360 minus, we have 265. So after that we get the angle for these two different angles. So that's what we did. So we can divide, since opposite angles are equal in the parallelogram, we can divide by 2, which we get the value of 115 degrees. So once we get 115 degrees of each side, so we can further reduce the triangle, not to make it complicated. I use the triangle law. I just get the half. So 150 Newton, we can transpose it into the another side. It will be same since a parallelogram. So 150, 100, and FR. Then the angle required, we already have one angle given. So as I mentioned, if two sides are, the value of two sides are given and opposite angle of the side with the missing value, we can use the cosine law. So here you can see, by using the cosine law, FR 100 Newton square minus 150 Newton square, 100 Newton square plus 150 Newton square minus 2 times 100 times 150 times cos 115. The result of that answer for that resultant force should be equals to 212.6 newtons. And while measuring, always be careful with the square, the value of squares, I mean the units. And once you get that one, by applying the law of sine to determine fx by using the sine law here, so since we got the value already, the only thing we are going to find is this theta. So that theta angle we can get it by using the sine law. So for sine law we have, so since we need to find this angle, we can use is sine 150 divided by sine theta, this one, equals to, we can use FR or other sides, since usually FR, since we already found the FR, 212.6 Newton divided by sine 115 degrees. So when you solve that one, the answer, the theta, you will get the answer of 39.8. But as per questions, we are going to determine the direction of resultant force. That means the angle made by the resultant force to the horizontal plane, which is this phi. So to get that phi, we already got theta, which is 39.8. So we just going to add these 15 degree angles. That will give you the angle of phi, which is 54.8 degrees. Next, we have a similar kind of examples. From here, resolve the horizontal 600 pound force in the figure shown into the component acting along U and V axis and determine the magnitude of these components. So here, same process, make a free body diagram. Internal angles, one is given, two internal angles are given. So to find that, one force is given, you are just going to find the value, magnitude of U and V, while the resultant it's already given. So for that one, 30 degrees, 600, the angle made, usually 30, make a parallelogram here, U and V. So once after you make a parallelogram, you have, let's just assume it's FV, FU, and resultant. So while making the parallelogram, these two angles 30 degrees are given. So another side should be equals to 30 plus 30, that is 60. That means this angle should be 30 degrees. Then by using the formula, the sum of internal angle of the triangle is 180 degrees. So just subtract these two by these two 30s by using 180. So the answer will be 120. So I can get transpose FV to the side just to use the triangle law. So here you have one side is known, two sides are unknown, then all internal angles are given. So that means we can use the sine law. So by using the sine law, you can find the value for FU, which will be 1039. Again, by similarly again using the sine law, we can find the value for FB, which will be equals to 600 pounds. So as I mentioned, always make sure that you follow the units, so you will not mess up with the answers. Then we have example number 3. Determine the magnitude of the component force F and the magnitude of the resultant force FR if FR is directed along the positive y-axis. So y-axis is where there's a resultant, so it's easy to compute. We have a F force which makes the 45-degree angle to y-axis, and 200-pound force which makes the angle 30 degrees to the horizontal plane or the x-axis. So same again, make a parallelogram for these two free body diagram by using the free body diagram. So it's given here 45, 30. So while making parallelogram, copy the same thing, 45, 30. So since it is 90 degree along the x-axis, we can just subtract 90 minus 30, which will be 60 degrees. So opposite angle, that is also 30. Then after that 30. So how can we find the remaining angle? So here also 45 degree, opposite angle 45 also. So the remaining angle is this 45. By using the same formula, 180 degrees is the total sum of angles of the triangle. Three angles of the triangle. So 180 minus 45 minus 60 minus 30. So the remaining will be 45. So which is 45 plus 30. So that side, the angle for that angle is 75. So here also we got the three angles. One side, the value for one side, two values are missing. So that means we can use the sine law. So by using the sine law, same, we can find the value for F, which will be 245 pounds. Resultant force, that will be 273 pounds. So whichever, while using the sine law, just make sure that the another ratio that you are going to use is known value, like 200 sine 45. Same here. So since the question is only asking the resultant force and the F force, we are done. We don't need to find any other direction, since direction it's already given 90 degrees. Then next is example number 4. In example number 4, it's asking like it is required that resultant force acting on the eye bolt be directed along the positive x-axis, and that F2 have minimum magnitude. Determine the magnitude, the angle theta, and the corresponding resultant force. Here it's a little bit tricky. So for these trick questions, make a free body diagram again and make a parallelogram if possible. If not, we can use the triangle. So basically here the trick is this one. Make a free body diagram here, parallelogram. It's much better if you cannot make directly the triangle rule, you can get the parallelogram, then just get the half of it for the problem solving. So here we can make a free body diagram F1, then bring the tail of F2 to F1 here, then draw the resultant force. So 60 degrees it's given, then the theta. So theta, it's slightly tricky. The trick is because it's already given the hint, F2 have minimum magnitude. So whenever you are computing the minimum magnitude, it should be 90 degrees. If you are going to compute the maximum, it should be 0 degrees. So for that, we just reduce and make F2 with the horizontal 90 degrees. So theta is 90 degrees. So after theta, the question is asking determine the magnitude for F2 and resultant. So F2 and resultant, here one side is, the value for one side is given and the two angles are given. So that means we can use the sine law. So by using the sine law, we will get the value for FR. If you are not convenient, you can use the cosine law, sine law, but it's slightly different. But you can use the sine law. Then not necessarily you need to follow the procedure that is being given here in the presentation. So by using the sine law, you can find the FR, which will be 400 newtons. Sine theta of equals to F2 over 800 newtons. By using this sine law, again you can find the F2, that is 693 newtons. So done with the example as well. Next is the addition of the system of the coplanar forces. When the force is resolved into two components along the x and y axis, the components are then called rectangular components. For analytical work, we can represent this component in one of the two ways, by using either the scalar or the Cartesian vector notations. So scalar notation is the the rectangular component of the force F are found using the parallelogram law. As I mentioned, everywhere you will be either using the parallelogram law or the triangle rule. So by using the parallelogram law, you will get the value F, which is the resultant force, should be equals to Fx plus Fy. That is what we are doing. So cos theta, by using the trigonometric law, cos theta should be equals to base divided by hypotenuse. So I can find this theta. So Fx cross multiply, so we will get the Fx, that should be equals to F times cos theta. And by using the sin theta, if you are going to find the vertical components, so for vertical components, this one perpendicular, by using the trigonometric law again, sin theta is equals to perpendicular divided by hypotenuse. So here perpendicular is Fy, and hypotenuse, this one, is F. So cross multiply, you will get the vertical component as well, Fy, which is Fy, that will be equals to F sin theta. So instead of using the angle theta, however, the direction of F can also be defined by using the small slope triangle. So that's another way. So Fx should be equals to Fx divided the ratio of Fx divided by Fy should be equals to ratio of A divided by C. It should be same, Fx by F. We are just using the slope. So cross multiply, you will get the Fx, that will be F A by C. Then if you are going to find the vertical component Fy, the ratio between Fy and F should be equals to the ratio between B divided by C. B is to C. So cross multiply, you will get the value Fy, which will be equals to minus Fb over C. Okay, not necessarily minus, it can still be plus. Then another way is by using the Cartesian vector. So it is also possible to represent the x and y components of the force in terms of Cartesian unit vectors I and j. So since the magnitude of each component of F is always positive quantity, which is represented by the scalar Fx and Fy, Fx and Fy, then it should be the resultant should be equals to Fx Cartesian vector I plus Fy j. So this will be the formula to find the resultant by using the Cartesian vector notation. So here we have some examples. We have a coplanar force resultants. We have in coplanar force resultants we have three vectors: vector 1, F1, F2, and F3, acting in three different directions. So if there are several multiple vectors, we can solve independently first. Here you can see in the diagram, you can resolve those all vectors independently by providing them with the horizontal component and vertical component. So here you can see F2x horizontal component, vertical component F2y. For the first one, horizontal component is f1x, or vertical is f1y. Then for the third one, f3y, f3x. So using the Cartesian vector notation, you can indicate all of those vectors. F1 should be equal to f1xi plus f1yj. f2 should be equals to minus f2xi, because f2 here you can see the negative sign, because you can see which quarter it's first quarter. Y and x both are positive. In the second quarter, x is negative, y is positive. In the third quarter, both x and y components are negative, while in the fourth quarter, x is positive, y is negative. So that's why in the second quarter, f2, it's negative f2xi plus f2yj. And for the third, y component is negative, that's why f3yj is the negative. And the vector resultant is therefore fr should be equals to, you are going to add resultant f1, f2, f3. So fr should be equal to f1 plus f2 plus f3. So the value of f1 is f1xi plus f1yj. So you are just simply going to add each of them, the value transpose here. So after that one, you are going to separate the x components, then y components. So when you segregate x component and y component, you can use this one as a resultant of x component, frxi, then resultant for y component, that is fryj. So remember this formula as well. Then resultants, if the scalar notation is used, frx should be equal to f1 minus f2x plus f3x. We just simply derived from here. Then fry, f1y plus f2y minus f3y. So which is, we can simply say it's a sum of horizontal components. So the frx should be the sum of x component of the given vector, then fry is the sum of y components of the given vectors. So there's no nothing to confuse here. Then next, here fr you can solve by root under summation of fx square plus summation of fy square whole square. So that is fr. So this is another formula if you are going to use the Cartesian product of the coplanar force. When we say coplanar, there is a more than one vector. Then if you are going to find the direction or the angle respect to the horizontal plane, that is theta equals to tan inverse the vertical component, sum of vertical components divided by sum of horizontal components. So we have some more examples, so let's proceed with the examples. So let's go with the example number 5. So example number 5 is asking to determine the x and y components of f1 and f2 acting on the boom. Express each force as a Cartesian vector. So you can see here in the diagram, f1 is the 200 Newton, which makes a 30-degree angle respect to the vertical component, and f2 in the second quadrant, then f2 makes is the 260 newtons, which makes the slope of this given value 5 along the vertical component, the resultant 13, then along the horizontal, that is 12. So in one side it's given angle, in another side is given the slope, so we need to use the two different ways. So solution is, we need to resolve each of those forces. independently. Here you can see, first resolve the first one, which is 200 newtons, making 30-degree angles. So when you resolve to the vertical component and horizontal component. By using the trigonometric law, you can get these values, which is this one, cos theta is equals to base open hypotenuse. So base is f1y over hypotenuse. Hypotenuse is given 200 newton. So when you cross multiply, you will get the value of f1x, that will be 200 cos 30 degrees newton, and fx you will also get by using the trigonometric formula, that is perpendicular by hypotenuse should be equals to sine theta. So sine theta perpendicular is this one, that is f1x, divided by hypotenuse, that is f1 200. So f1x should be equals to 200 sine 30. Then for the solutions, you already have f1, the values for f1, then f2 given. So again, by using the slope, you solve the slope also here. So by using the same formula, cos theta f1x, so that is what you got. You can solve this f1y 200 cos 30, that should be equals to minus 173 newtons. Then 200 sine 30, it should be equal to 100 newtons minus. So another is the vector at the fourth quadrant. So for the fourth quadrant, it's given in the slope 5, 12, 13. So that one we can use the same formula, the ratios, by using the ratios that I mentioned a while ago. f2x would be equal to 260, because f2 is 260, times slope base by hypotenuse 13. Then for the vertical components, perpendicular by hypotenuse 5 over 30. So we can solve this also. By solving f2x, we will get the value of 240 newtons, and f2y you will get the value of minus 100 newtons. Then by using the Cartesian vector, because we already have a values f1x and the value for f1y, so just substitute here. After substituting for f2 also, you will get the Cartesian vector. Once you get the Cartesian vector, you have a answer, because it's asking, the question is asking, express its force as the Cartesian vector. So you don't need to solve further. But if you still want, you can solve the resultant values, but not necessary. Then next we have example number 6. For example number 6, it's asking the link in the figure is subjected to the two forces F1 and F2. Determine the magnitude and the direction of resultant force. So same process again. So if the values for F1 and F2 are given, but it's not, we need to solve the resultant force. So same again, make a parallelogram, free body diagram using the parallelogram law. Then find the angles, respective angles, then magnitudes. So parallelogram law, parallelogram law most convenient way, but we can use this new Cartesian formula as well, by dissolving two different vectors, finding the vertical component and horizontal components. So frx should be equal to f1x minus f2x. f2x because it's in the second quadrant, so x is negative. So we already have this value f1x here, just use the basic trigonometric law. So like sine theta equals to perpendicular by hypotenuse, cos theta is equals to base or adjacent side divided by hypotenuse, tan theta is equals to perpendicular by base. So by using the formula you will get these values. Frx would be equals to sum of fx, which will be equals to 236.8 newtons. Fry, which is sum of all the components along the y-axis, that should be equals to 582.8 newtons. This is where we get the answers. So since we got the resultant, we still need to find the angle. So angle for a resultant force is theta. So by using this formula, Fr is equals to root under summation Fx whole square plus summation Fy whole square, we will get the resultant force. That should be equals to 269 Newton. So once you get resultant force, we can use the formula, this formula, theta equals to tan inverse summation Fy perpendicular or y components by x components. Just substitute the value you got from here, 582 divided by 236.8. So you will get theta also 67.9 degrees. That should be the answer for the direction. Here. Then next should be the Cartesian vector. So the remaining, I think we are half of the lecture for this chapter 2. I will be breaking this chapter into 2 videos so that you can stop and you will not get bored. So the remaining part will be in the another video.